Okay, so welcome to the first lightning talk session. We've got 5 lightning talks scheduled for this and 5 more for this afternoon. Because that probably leaves us with a little bit of room at the end, I'll try and do something that I did a couple of years ago and worked then. So there's no reason to suspect it won't be a rollicking success now either. If anyone's got a slide deck that they particularly want to present and they think is relevant, and you're willing to put up with the mocking from the crowd if you've got that assessment wrong, let us know when we've got time at the end, and we can get it back to the presentation team. Before I start, I think I'm going to take the first slot, and I'm going to talk about why conference Wi-Fi is hard. Yeah, there we go, big surprise. Yeah, I haven't got slides. Yeah, so conference Wi-Fi is hard. Everyone will have noticed this week, especially on Monday afternoon, that conference Wi-Fi was not only hard, but also hard to use. So clearly that's not good. We know that's not good. APIA, Internet NZ, Sky City know that's not good. We're working really hard on making that less not good. A little bit about the past, about how we came about to this. So we are using Sky City's Wi-Fi. They are the access points in the roof. They are Meru Fortinet devices. Making a decision to use the hotel Wi-Fi isn't particularly an easy one. It's not one that we did just because, hey, that sounds easy. We met with them, and we've actually personally run another conference in advance of this just to test the Wi-Fi. So the NetHui conference was run back in July and worked, great. In between then and now, the conference has actually run the Microsoft Ignite event, which was 2,500 people on this Wi-Fi, and it was fine. And then, something happened. I'm told software upgrade. Anyone been there before? And now the network's not fine. So we've been capturing debug, working with the vendor, working with Sky City. They've been really good about trying to find out what is up. They made what they think are the right config changes last night. It is looking better now, but the problem with all these things, and the reason why conference Wi-Fi is so hard, is unless you can invite 1,000 of your best friends with 2,000 of their devices around for a massive LAN party, you know nothing. This worked great last night, as every other night before it. It's still looking okay now. Like I'm on the right Wi-Fi network, yeah, and I'm getting single-digit ping times rather than quadruple-digit ping times. But again, we're not going to know until we get actual people in the room. So what the plan is we like those config changes. If come lunchtime those config changes don't seem to have sorted out all of our wireless issues, they're going to downgrade the controller and all the firmware to the version that was used back at NetHui. That will take 45 of our Earth minutes, and during that time there will be less Wi-Fi than there was. But hopefully after that there will be more Wi-Fi than there was. That's the present. Future. The APIA board realizes that this isn't good enough. So what we're going to do is start a review of how wireless networks are provided during APRICOT. That's going to be led by Dr. Philip Smith. He'll pull in anyone else he thinks necessary. We're going to go out and chat to the IETF and ICANN conference organisers to see what the best practices and consider things like purchasing hardware that we truck around the world and deploy in known states. Now that's hard. Some of the countries we're looking at for hosting these events, that's not going to be possible. So you're in a situation of you rock in with a known good set of hardware. You can't actually do that regulatory-wise. Conference Wi-Fi is hard. So we're going to do that. We'll let you know of the outcomes of that. So please, give us nice, calm feedback about the Wi-Fi. You know, it is important that you guys let us know if it's good, if it's bad. Don't angry tweet, please. It doesn't help anyone. But you know, just come and see us and let us know what your experiences are. As I say, it's looking better for me this morning, but I don't think all of my 1,000 friends have turned up yet. So thank you very much for your perseverance with it. Again, we unreservedly apologize. So cheers. Gotta love doing stuff like that, right? All right. First up, in terms of lightning talks. Oh yeah, we have Joe Abley with how our prefixes got hijacked.
Should I use this one?
Yeah.
Oh, it's down here, is it?
Well, you can use this one stand here if you like.
Oh, I don't really care.
I guess.
All right. I remember years ago, we did Nanog in Toronto in February, which was a stupid idea. It was minus 40 Celsius. Yeah, it was really, really bad. But one of the things we had to do beforehand was explain to the hotel, who had just spent an unholy amount of money with Bell Canada, to have Bell build out Wi-Fi infrastructure in their hotel, that we wanted them to turn it off and not use it. It was very, very unpopular until we got to the point where we actually got numbers out and described the average Nanog attendee is carrying 6 Wi-Fi devices. And that's just the average person. So yeah, that apparently convinced them, and it worked out. So this is just a couple of slides. I didn't write these slides. We have a guy at Dyn Research. You may know the company previously as Renesas. It's based in Hanover, New Hampshire, and they became part of Dyn, I think about a year and a half ago or so. So they are now Dyn Research. You see them quoted all over the place. They run a nice blog when they see interesting things that are hijacked. And the reason they do that, and it's timely, and the reason the New York Times calls them and says what's going on with this thing in Pakistan or whatever's happening at the time, is because people like Doug, as far as I can tell, just sit there and watch a stream of logs all day, every day. And when they see things, it's like the Matrix with the green things coming down the screen. They just stare at the BGP tables and they sense things. And at the beginning of this month, which is the button? That one? Yeah. Oh, I see. All right. I don't like these things that appear slowly. At the beginning of this month, they suddenly noticed that APRICOT seemed to have moved. That obviously somebody was trying to announce the address space. There's a /20 that's assigned by APNIC for use by APRICOT. It's only used once a year. So you think about it, it's kind of prime territory for anybody else who needs a bit of an address space to send a few billion spams or something to use in the meantime when APRICOT's not on, because chances are nobody will notice. But in this case, it happened to happen in February, and we knew APRICOT was coming up, and people were coming here, so it rang some bells. And suddenly we thought, you know, is APRICOT actually happening in New Zealand? Or is it actually happening as it looks like in the routing system, where it's coming from Africa? Has it moved? And we thought probably it hasn't moved, and then we thought, Doug said, you know, Joe, who do you know at APRICOT? Are you going to APRICOT? And I said, yeah, I'm going to APRICOT. And he said, how do we find out what's going on with APRICOT's network? I mean, of course, it's happening in New Zealand, so the answer when you want to know what's happening in New Zealand is you ask Dean, because that's actually the most practical and direct way of finding out any kind of answer. So we asked Dean, and does this sound suspicious, we said. And Dean said, sounds quite suspicious, yeah. So I don't remember at this point whether we were actually seeing the /20 being announced, but we certainly, I'm guessing the /20 wasn't really seeing any traffic, because all the traffic was following these /24s. The other interesting thing was that this is one of the rare occasions where you can actually say, does the origin match the rower? Because the APRICOT address space does actually have rowers. And no, it doesn't. And this, I think, demonstrates clearly the usefulness of rowers in general, because if it wasn't for that, we wouldn't have realized that APRICOT hadn't, in fact, moved to South Africa, because that would have been a perfectly normal thing to assume. But with a rower, we'd be constantly sort of sure, and now we know for certain. So that's good. Our PKI is certainly worth the money there. So the AS numbers that were originating these routes, there were a number of them. And this is a little snapshot from one of the products that Dyn sells, that, you know, ex-Renesas product, called Dyn Internet Intelligence. It gives a sort of a graphical representation of how you actually reach particular endpoints. The common factor in this whole mess for all of these /24s was AS260, which looked from where we received the updates like it was in Amsterdam. They're actually in other places too. But AS260 was generating all these things from various AS numbers in South Africa, which had never in the recent history been announcing anything. There are AS numbers that had been registered but never actually used. So it looks like AS260 was just synthesizing these origin ASs and just prepending them before they originated the routes. And that seemed to be what was happening. So we talked to Dean. Dean talked to Mike. Mike said, oh yeah, that seems bad. So what happened then was we started advertising the /24s from here, just to have a bit of a fight in the routing system, see who can win. But really, Amsterdam versus New Zealand is Amsterdam, isn't it? It's going to win. So that didn't really work. But then upstream of AS260 is GTT, and they're reasonable people, and we said these things all seem to be a bunch of crap, you should block them, and they did. So that was the end of that. So the interesting thing really is not so much that this happened, because I think we don't need too many reminders that this stuff happens all the time. It's a slightly useful reminder that longer prefix hijacks routes are going to steal your traffic, and you might not even notice if you're not using those particular parts of your /20 that parts of your /20 can't receive traffic. It is the kind of thing that's great on a help desk, though, when you've got users that say, well, I can't reach this, and you say, well, I can reach it. You're obviously just crap. But no, you've got an address out of a different DHCP pool, and your route's been hijacked in Europe, and you can't go to that web page. That is the kind of thing that happens. I don't remember what else. I got distracted by Jeff earlier, so I forget what else is happening here. Oh, so the other thing is, AS260 is still spewing all kinds of random routes from all kinds of random AS numbers as well. So if you feel like sort of filtering a bit and becoming part of Jeff's up-and-coming statistic on how much of the internet can't be reached through various ASs, maybe drop all these routes, because they all seem to be quite awful. And don't trust the origin AS, I guess. And that's it. Any questions about APRICOT?
Awesome. Any questions?
Well, they blocked the APRICOT ones. Yeah, they blocked the APRICOT ones from 260, but they are still receiving all kinds of other junk, so they apparently don't care that much. Well, we can't see. So I don't know. I don't know if we actually talked to GTT and asked them that sort of question. I think we're just happy.
We haven't asked them that. We just said, please stop, and they said, okay.
Yeah, that was good enough at the time.
Yeah.
He's a South African. You can blame him.
Oh, hi. Welcome. Stop announcing my routes. No. Yeah, it's an interesting point, and I mean, a little bit of an interesting point about the address space. It's not actually APRICOT address space. It's the APNIC conference address space. So if you're holding a big conference in the APNIC region, you can have a chat to the APNIC folk and get yourself a /20. That's kind of cool. You got to give it back afterwards. That's the downside, right? But this address space does move around. So it was used for the APNIC meeting in Jakarta back in September. It was used for the APRICOT meeting in Fukuoka back in February. So seeing this come from all sorts of places isn't unusual. Seeing this from a whole lot of upstreams isn't unusual. And I'm pretty sure it was used for the South African NOG at one point as well. So seeing it in route filters in and out of South Africa wasn't unusual either. Okay, so this is really a public service announcement for please update your filters, because if you've had this /20 on your network on your upstream at some point, then your filters are going to be set to allow it. But this thing moves around a whole lot. As you will have noticed if you've used a search engine such as Google this week and it thinks you're in Indonesia. The reason it does is because last time you used this, you were in Indonesia. So yeah, there you go. Now, next lightning talk, Jeff. On everyone's favourite topic, Pride, Prejudice and Zombies. Thanks a lot.
Where's the clicker? This is a presentation about... Actually, I think it's about the Internet of Things, if you really get down to it. And the bright and wonderful future that awaits us with the Internet of Things. So as you may have gathered, we do a huge amount of measurement around the internet. And the way we do this, because we're trying to find the internet as it looks like from you, the user. So what I try and do is actually get you to do what you always do. And what you always do is fetch URLs, right? So we actually embed in an ad that uses Google, thank you Google, this ad. And you don't have to click it, and I'd wish you don't, because, you know, it works best when you just leave it alone. As soon as the ad is impressed, a bit of HTML5 comes up, and it fetches 3 URLs. So all it does is fetch a one-by-one GIF. It's tiny, right? It's not exactly anything in there, and it's not meant to display, so you're not actually meant to see it. Now, the problem with the internet, you know, there's zillions of them, but one of the things is that all you network operators want to make life easy for your customers, don't you? And so everyone fills up the net with all kinds of crap called caching. So the DNS caches, all this stuff normally caches, you know. And if I'm trying to see what you're doing and I'm trying to get your DNS query back to my authoritative name server, I don't want a cache, because that'll stop me seeing you. I don't want a web cache, I don't want a DNS cache. So how do I stop that? Well, I make every name unique. So every time you get this ad, and even if you get it twice, lucky you, the second time will have completely different DNS name components in the URL. So that the URLs are so dumb that they don't figure out, or at least the caches, it's the same one-by-one GIF, you know, it really is. But because it's got a different name, they go, right, entirely different thing, let's fetch it directly from the source. So I push out all of these unique URLs. Now, Google, I think they make 97% of their money from ads, right? Huge amount of money made from ads. So they're really good at serving ads, because this is where the money comes from. So at the moment, they're serving about 4 million ads a day. In the middle of December, they got really enthusiastic and we're doing 12 million a day. Thank you so much. I really appreciate it. That's a huge number of unique URLs every day. Because I do this, every ad has at least 3 components. So I'm pumping out approximately 12 million unique domain names per day, right? They're unique. And they only ever get used once. And equally, there's 12 million URL blots, right? And they only ever get used once. Because if you get the ad a second time, different URL, right? How do I make sure that? Well, okay, the DNS is once, the TTL is 1 second. Get rid of it. It's rubbish. Don't keep it. The URL, once, only once. So what should I see? Because I'm the authoritative name server and I've just defeated all the caching. So what I really should see is the queries to resolve the name and the URL fetch to get the object. And I should see that basically once. Now, the DNS is a little bit obsessive. Thank you, Mark Andrews. It's probably very obsessive. And sometimes once is an understatement, and it just likes to ask a few times just to be sure to be sure. So, you know, I might see a few queries, but they should be tightly together in time. Within the same second would be a really, really good idea. So this is a log. This is a log of the DNS queries. There are 2 fields there that are really quite interesting. The first field is the query time. All this happened on the 15th of December at 3 o'clock in the morning UTC. What's in this unique name? The time I generated that unique URL. You see that column? Now, unless the Google Ads system is truly bizarre, and it's not, the time between generating the ad, generating the unique name, and having the DNS query should be about a second, because we live in that kind of world, right? Have a look at those dates again. You know, just work it out. There's something really, really weird going on. This is, you know, last month's ads coming back at me. And you kind of go, wow, maybe there's a lot of this shit. So let's start comparing the query time to the name time. And let's do a distribution, 1 day, 1 server. Now get this is in days. Not seconds, not milliseconds, days. And there's an awfully big peak, right, at around 500 days old. Holy shit. Again, at 600. No, we can do better, 800, and the peak was 1,200 days old. Now, I'm sorry, I've never asked anyone the same question twice. This is not me. It's you. And I have no idea what you is, but that's getting pretty weird. Right? That's not a TTL, that's just overcorrection. 1 day, 1 DNS server, that's actually the cumulative load. 1 day, 1 DNS server, I saw 60,000 of these. And, you know, where was the halfway point? I'd do all servers for 60 days. 50% of these zombies are more than 6 months old. Holy crap. You mean to say that my DNS authoritative name server spends a huge amount of its time answering queries for non-existent people? And the answer is, well, yeah. It spends a huge amount of time answering queries that are already answered before, and you're just sitting there going, oh shit, what was that answer again? Why? No one wants it. It's shit. You've gone. The ad's over. So, this is getting really, really weird. And I thought, well, okay, I've done queries per day. What about inside the day? How many times do you ask me a day? That's a log scale. So most of the time, even though I set a TTL of 1 second, you ask me once a day. That's wacko. But as usual on the internet, anything you could see, you will see. There's one particular instance out there that said, no. I'm going to ask you every 3 seconds, just in case it changes. I'm like, I'm giving you the same answer. Nothing altered. Weird. So funny distribution, heavily centered at 1, but a distribution throughout the day. I zoom it up just a tiny bit. This is from 1 a day to 72 a day. 2/3 of all queries are only once a day. That's really weird. But there's another thing too. There's a peak at 32. Do zombies use a 32-hour day? What's that peak doing at 32? I'm like, that's a bizarre timer. What happens every, is it 40 minutes or some such crap? And 40, these are not real, right? This is not a conventional timer. This is just some zombie in some warped time zone where a second is not the second that we know. There's some other periodicity flying through in that profile. This is wacko. So then you're kind of going, am I seeing the side effect of deranged web proxies? That they've cached the URL name and they're just asking the DNS. So it's not the DNS that's gone wacko, you can breathe easily, Mark. It's not you guys, it's the web, right? Because whenever anything's wrong, blame the web, right? It's true. So let's look at web zombies. Yes, there are web zombies. They're really, 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 really weird. Look at that distribution. Again, I get zombies up to 3 years old because the zombies have the same name. But once you become a zombie, there's no decay factor. It's the same in constant age. Zombies never grow old, right? Once you become a zombie, that's it. It's constant load forever. Every time I pump more ads, that base level radiation goes up, right? It's just a rising tide of shit zombies that just never, ever, ever, ever die, right? This is getting really, really weird. Do the same distribution. 50% of all zombies are less than 4 days old. But once you're more than 4 days old, you'll live forever. The repeats have a different kind of distribution. Most of them only do it once a day, but there are a few outliers that one's giving me the same URL fetch 300 times a day. Thank you very much. You really needed that one-by-one gift, didn't you? Distributions are different. It's not the URLs that are causing the DNS. There are 2 zombie factories and they're competing with each other, right? There's the DNS zombie factory trying to populate your DNS resolver, and there's a URL zombie factory just trying to populate your web server, and they're different factories. So, this is really interesting, isn't it? Nothing's forgotten. One-off URL, only ever shown to one person once, and it's kind of gotcha. Gotcha. I'm never, ever, ever going to forget it. You can use this. Because we were, right, this is it. What do you want me to store? I'll just put it in a URL and ask the DNS. Read. You can read. You just watch all the queries and wait. It'll come back. Just be patient. At least once a day for half of them, so, it has a 1-day read time, but it's right.
And it's cheaper than Glacier.
So, you've got read, you've got write, you need delete. Sorry, can't do that. Thank you.
Awesome. Disturbing. Anyone got any questions for Jeff? Yep, okay.
Have you tried to knock out the URLs you never generated? Are there a bunch of queries to those? So do you get a load of NXDs as well in a similar format?
Am I getting completely foreign queries to my DNS authoritative name server? Oh God, there's a whole bunch of folk who scan the address space and just send me queries, That's just part of the normal background radiation of being a DNS, name resolver. That's normal. What I find really abnormal is this whole idea of machine intelligence where the machines are going, I have all this memory and I need more one-by-one GIFs. I better ask again and again and again and again and again. Christ, I think I've filled my memory. Let's ask again anyway. That is weird. And then on this DNS cache, I have a TTL of 1 second. I'll stuff that. I'll just make it a day. I need to fill my memory because it's empty. What else will I do with my memory? And that seems to be what's going on. It's just constant background of crap.
So I guess kind of a related question. Have you tried returning like 404s for the web ones or NX domain for the DNS ones and seeing if you can make zombies
I don't want to
die?
discourage zombies. I enjoy them.
I want to see a zombie killing lightning talk for next year.
You've been doing these ad experiments for quite a while.
Yeah.
And like, what, 5 years maybe?
Well, 3 years.
3 years.
That's what you see. I've been doing it for 3 years.
So you haven't seen, apart from the introduction of new DNS names and new one-by-one pixel GIF URLs, you haven't seen any other increase that would be... The thing that I thought of was, since years ago, we've had web caches that do prefetching. And then they will choose the corner of the graph, which is low TTL and frequent access.
You're saying that there's this really good cache out there that's figured me out. And it's looked at the pattern of URLs going, Christ, if I ask for one of these and put the time at 10 seconds in the future, I'll get the bugger. And I'll load up the cache before the ad gets delivered, right? I'll look out for it. I will look out for it.
So yeah, there's two things. One of them is that these things will actually scrape the page on the way through and pre-look up things and fetch things so that when the client asks, they can respond quickly. So you're getting double hits then anyway. Then you get caches that are talking to their sibling caches before they talk to anybody else because I might as well refresh from him, which potentially is resetting a timer for how often people are interested in this URL, which is causing it to go and prefetch it more aggressively and ask the other one.
This goes on for years.
And the reason I was asking about how long has this been happening and has there been any other things, because when did Unbound implement the DNS hammer type thing? Because Unbound, which is now very popular, does this exactly the same kind of proactive cache refresh before it's asked for things.
So hammer, if you actually did the hammer thing, which I never got finished. So if you actually implement hammer the way the draft says before we got bored and ignored it, you will only do a fetch if you get a query during the last 10 seconds of the TTL or something. But you actually need a query.
So again, you'd need web caches talking to each other, looking things up, stimulating the caches to make them prefetch more.
But then you would see a correlation. You would see a correlation of web to DNS. And I'm just saying the DNS has taken on its own form of intelligence. It is now an evolved and superior life form, and it's generating zombies all of its own accord, Joe. It's just that good. It's, we built it and we're professionals and we're really good at it.
So, you could explain this away by people who ignore TTL and have a forwarder chain, right? If you, a forwarder pointing in a forwarder.
I think it's fantastic. At Dyn, right, we care about extra 2 milliseconds in query latency because to be honest, that's the only thing you can measure. You can't measure end user experience, so you fixate on the one number you can look at and you compare yourself with all your competitors. So the whole push to try and make the query latency as quick as possible has resulted in just an army of the Walking Dead wandering the streets of the internet.
There is another theory about why these zombies exist, and that is that some forwarders take 6 years to process the request and then ask.
I like Warren's zombie cyclotron idea more.
Hi, Mathieu. Do you have any stats on V4 and V6 zombies, where we see them more often?
Sorry?
V4 and V6 zombies.
V4 versus V6 zombies.
I've done some V6 transport DNS experiments, and it was so depressing I stopped.
Awesome. Thank you. Yep, okay. You can see I'm being a little bit more permissive on time. I think it's good though, right?
Sorry, quick question. Did you actually do any investigation on what these zombies are? Are they proxies? Are they PCs out there? Or you just haven't had the time?
It's kind of, you're looking for something, you find this other crap, you go, God, that's amusing. And everyone says, have you investigated it? You seriously looked at this stuff. I haven't had time yet, but it's, feel free. All you need to do is ask the DNS, right? And then listen. Echo, echo, echo. You can do it too.
Awesome. Thanks, Jeff. All right, next up we have Kevin Cheer with DDoS protection techniques.
Hi, I'm Calvin. I'm Equinix and I'm stationed in Asia Pacific, and my home base is actually in Singapore. So today I'm actually talking about DDoS protection, or rather the mechanism that is commonly used in our IP transit services, or our Equinix Connect. So basically, the three agendas: what's the DDoS attack, the common mitigation techniques, the methodology, any other methodology for DDoS protections. So basically, let's go through the fundamentals of DDoS. The whole objective of DDoS is actually flooding you to take your service offline, be it volumetrics or service port level. Volumetrics basically provide you a service degradation during that period of time. Service port attacks is more to bringing down your service. So for RTBH, there's only come with two variants. One is the source-based and destination-based. The most commonly used is actually on a source-based, destination-based. Is because the source is always unpredictable and you can never really find who is the true sender, and it could be a spoof address. So how RTBH can be set up is in a very typical way. I have a simple diagram of the charts, assuming that I have a customer A over there, and I have my own prefix injector, which meant for my NOC usage, and the RTBH router that actually announced the routes. So in terms of peering base, the RTBH actually uses IGP in your own internal network and also a eBGP back to the customers. So when the customer actually finds that there is an attack to the destination, they basically send in a /32 down to my RTBH router, and my RTBH router will then translate these community tags to the edge routers up to the respective upstream provider to actually suppress the traffic towards them. So this is coming from the customer perspective, but assuming there is a customer who is not willing to peer to our RTBH router, we are doing on behalf at the prefix injector, which will be initiated by the NOCs. So the RTBH implementation is fairly simple. So the RTBH router got to ensure the send community tags enabled and only permit net blocks that actually belongs to the eBGP neighbors, and just to prevent any accidental oops on advertising. And of course, up to /32. So the edge routers basically got to accept the RTBH community tags, translate it to the next sort of now, basically discard, and also create a rule that actually translates it up to the upstream provider community to actually allows them to drop these packets further upstream. And of not forgetting, S-flow and net flow is actually one of the key elements to actually diagnose, or rather to ensure that the traffic, what kind of traffic is coming to the network and which destination that is actually flooding the targets. So the drop at RTBH is fairly simple. RTBH basically drops every single traffic, which means your server will be totally offline, and you can't really restore your services until the attack stops. Yes, there's ways that change your IP addresses, but it's just a matter of time that this address will be then taken offline to the internet again. So, sorry, for the RTBH, this is more for the volumetric base, which means that you just want to flood your pipe and we just take them down, basically. So for BGP flow spec, not very sure how well is the community actually implementing flow spec. So it's basically a new BGP NLRI, network learning reachability information. So basically it's a parameter that actually allows the edge routers to actually process that particular packet coming from a flowback server or the routers to either what kind of mitigation techniques, probably could rate limit, you could every tag with DHCP colors for QoSing, or even redirect and even discards. So for flow spec, we are more targeting into the service ports level, just to ensure the service availability is able to continue, just like, at a slower rate. So in flow spec, in a single attacker, assuming we know the IP addresses, so this is a snippet of the Junos. So the flow spec router perspective, we just got to set certain filters up. Destination is source, what kind of protocol, and the port, and what action do you really want? Assuming I want to just rate limit this HTTP process to 1 meg, and I just export it out to my edge router, which IBGP. And yep. So at the edge level, we accept anything coming from the flow spec router, process that particular LNRI tag, and accept every single thing coming from the internet. And any other service ports other than the port 80, you have your own line rate, the subscribe rate, and anything coming from that source to the destination will then be rate limited at 1 meg. So basically this is just to contain the particular attacker. So what happens if there is large inbound, probably DDoS to a particular service ports? Instead of having a source address, we just limit the source address, go to the destination, and just put down the rate limits. The rate limit is just one of a particular option. You can actually do redirection. Redirection probably to your scrubbing center. You can probably discard it, or any way you want it to be. Okay, the flow spec drawbacks are basically your edge router going to have a performance hit because one, they are basically a firewall doing the rate limiting and shaping, so it's going to suffer quite a fair bit. And at this present moment, the key problems that we face as a service provider to customers is that when do we actually find DDoS is hitting our customers? It could be a single GRE tunnel that the customer actually is having with a scrubbing center. We see multiples of traffic going through there. We can never really mitigate such impacts to them. So is there any other mitigation for DDoS for the customer could probably use? Yep, you can actually go down for scrubbing centers, or probably we can offer, or you guys can offer an inline scrubbing appliances where all aggregated upstream providers coming to your network, everybody will offer clean pipe services. Yep, that's all.
Awesome, thank you. Any questions? Oh, yep.
So these are blocking the attacks when the attacks got onto your network. Is there a way to block the attacks further away from you? Because that may consume all the bandwidth that you have on your network.
You're stating that if my customer is actually doing an attack out from my network, you mean?
So your customer is on your network,
yep.
And if the attack traffic is traversing your network and the only way to block it is to use RTBH or flow spec, by that time it's actually a little bit too late, it's already got to you. Is there a way to block it before it gets to you?
Currently, to be very frank with you guys, it's actually very reactive. We actually monitor the traffics, and only when you see an anomaly in the traffic pattern, we then do the RTBH or even the flow spec based on the telematics that we have.
Just a comment for the answer. Most of the upstream nowadays have a 666 community where you just announce a /32 and they do the black hole for you. So if you get a massive DDoS, at least you can ask your upstream to black hole that traffic. Yeah. If your upstream is not doing this, change upstream.
Absolutely. I've been going around a lot of Asia recently, talking to large corporates, and yeah, like there are certainly some large providers that don't offer that, and that's been exactly my advice to them.
From my experience, especially in Asia, the upstream provider actually allows you to do RTBH community tags, which is on the edge router point number 2. Basically, translate your internal community tags up to the upstream providers, and you can actually do that. But it seems that workers, especially in Australia, they don't actually practice RTBH. So I may be wrong, but it seems that they are not implemented yet.
Okay, any more questions? Oh, yeah. You can probably make your way to the stage after that question if you like.
So I should say I'm James Tin from Akamai. So when you advertise a /32, can that go beyond your network, and how far does that go? Because using BGP, they only accept
apparently the
/24s.
/32 will be only accepted with a community tag. Anything that is not tagged with a community tag and you're advertising /32, you just drop off at the edge router. Well, the internet is only accepting anything that is 24 minimum.
There's been a number of experiments.
There's been a number of experiments around this, and that's basically a piece of popular mythology. It's not true. /31s and /32s do make it round various places. It's become a topic of interest because Aaron, in their last IPv4 address pool, is actually contemplating allocating /25s and onwards. And folk are going, oh, it'll never work. And other folk are going, you know, that's bullshit. It does actually manage to work. It may not be everywhere.
Yeah,
and it
I think the
probably
adoption
isn't,
rate is a little bit lesser.
But if you do these experiments, you will find they propagate more than your AS, right?
Yep.
So this idea of length filtering, oh, 24 is everywhere, is a different statement. You are more likely to get a 24 everywhere, but not assured to do so. Not everyone carries every route, problem A. B, 24s are more likely than 25s, but that doesn't mean 25s won't work.
Got it.
Did you have any experience on how far those YouTube 24? No, just far, some? Yeah.
Stuff went boom.
Yeah.
Turned on like 80% of traffic came back.
Okay.
Works better than you think.
Okay. Cool. Thank you very much, James. Thank you. All right. So next up, James Toon from Akamai, the who, where, and how of DOS attacks. Meh.
I thought this was apt for New Zealand. So I'm James Toon. I've been at Akamai for 2 years. Previously, before Akamai, I was at F5 for 3 years, and before that, I was at Bluecoat for 4 years. So all the stuff that we talked about this morning, that's why I was quite interested in some of the techniques that we've been discussing. So DDoS is I think that's quite challenging at the moment, and it's actually really difficult as an enterprise organization to mitigate DDoS attacks. If you're a bank, then mitigating a DDoS attack, you don't have enough capacity, and that's why a lot of the Australian banks are actually using our platform, Akamai's platform today. So I'm going to discuss about, we have a thing called sorry, yeah. We've got some doctors in the room, and I probably should concentrate a bit more on what I'm saying before I try and think about what I'm going to say next. All right. So Akamai's platform, how can we help mitigate DDoS attacks? So at the moment, our platform is a very distributed platform. I liken it to a reverse proxy platform, an application delivery platform that's distributed extremely widely across the world. There's about 210,000 of these boxes out there, and each of these is a reverse proxy. And we deliver roughly 15 to 30% of the internet today, and we don't deliver any adult content. So if you have a guess of what percentage adult content is on the internet, anyone have a guess? 70, yeah, good guess. When I was at Bluecoat, I saw it roughly 50 to 55% in Australia and New Zealand. So if we are only delivering non-adult content, then we actually have a huge visibility of the internet. So let's say that 30 jumps up to 60, and then we don't do any email, so that means another, I don't know what, 10% for email. And so we generate heaps of data. So we use our delivery logs, our web application firewall logs, and we generate about 20 terabytes of daily attack data and 2 petabytes of data every day. So we use this information and we mine it. So we have a big team in Israel that essentially are data scientists and continually mine this information. So we can understand what a user has done before they've actually gone and accessed your website or your network. So we can determine a user has done SQL injection attacks over here, or distributed denial service attacks over here, or has participated in scraping before they've actually done anything on your website. So we have something called data visualizations. It's called stateoftheinternet.com. If you go there and you click on resources, I don't know if I have a clicker here, sorry. Yeah, if we go to resources and then go visualizations, you'll be able to see all the attack traffic that we see. And who are the biggest attackers that we see? Right now, it's these guys. So we see a huge portion of the attack traffic initiated from this infrastructure. And when I was giving this speech at a tech day for our customers in Australia, Qantas put up their hand and they said that the record that they had for a machine to be compromised was 32 minutes. An intern had put up a Linux machine in AWS, turned on Apache. 32 minutes later, that machine was compromised.
Is that the longest time or the
Shortest time. So when I have customers who move from the physical data centers into AWS, we're finding that most of the Australian and New Zealand enterprises are, they're getting a lot more reconnaissance and probing, a lot more attacks. So up to 20 times more attacks. One of the customers based in Queensland said to me that they get 10 to 20 times more reconnaissance and probing attacks in this infrastructure compared to their physical data centers. And why is that the case? It's because instances are being spun up here every minute. And so there's new machines coming on, so the attackers are just constantly scraping the entire IaaS infrastructure, looking for vulnerabilities, seeing port 80 open, port 443s open, delving through, looking through all the fistulas, looking for a vulnerability, then compromising that host. And then from there, they do either bit mining, Bitcoin mining, or initiating attacks out from there. So this is updated every hour, so I'd highly recommend just having a quick look in there. See if you can, if you can see a lot of stuff in there that is of networks that you internetwork with, then maybe you can reach out to them, help clean up the internet a little bit more. So how does our platform stop DDoS attacks? So our motto, or the reason why Akamai is around, is to make the internet fast, reliable, and secure. And that's probably very similar to your infrastructure. Why are you delivering a network? Is to deliver the internet faster, more reliably, and more securely. So when a user accesses a website that's delivered on Akamai, we become the ingress point for that website. We become the A record. And so if we don't have the content, we terminate it, and we terminate the request, and we establish a request onto a parent proxy and then onto the real web server. That real web server could be in AWS, could be in a data center. We don't really care where it is. And the response is cached on the way back. And at this point here, we are a full web application firewall, so we can look at the traffic, block the SQL injections, cross-site scripting attacks, while making the user experience faster. This guy usually gets a 50% improvement in performance even if we don't cache any content. Some of the banks with this platform now, they're getting their pages loaded normally in 6 seconds in AWS for an Australian user. We now reduce that down to 2 seconds with our platform. So it allows them to deliver local user experience around the world without having to deploy infrastructure everywhere around the world. And so when there is a DDoS attack, the DDoS attack lands on an Akamai node within the same source network typically as where the attackers are. So we are 95% away from all the users on the internet in one hop. So that means the attack traffic coming from Russia or China or the USA lands in an Akamai node typically within that network of the source before it gets across the internet, before it comes into where your origin infrastructure is. So we're able to block the attacks as close as possible to the source. And I'll just do the animation again, if a legitimate user wants to access the network and they take down an Akamai node, that's not a problem. We will resolve the best next available Akamai edge and deliver the content to them. So even if 50% of the Akamai network is down, we should still be resilient enough to deliver your website. And our customers term this for us the DMZ0. They allow Akamai to extend their demilitarized zone from the edge of their perimeter infrastructure all the way to the edge of the internet. So that's the platform of the Akamai Intelligent Platform. That's the content delivery network. We purchased a company called Prolexic 2 years ago. And how does Prolexic mitigate DDoS attacks? So Prolexic mitigates DDoS attacks by operating scrubbing centers. So we have 7 scrubbing centers around the world. And if the scrubbing centers here, let's say, if we take away Akamai and just look at native internet, you've got the user on the right-hand side that will make a request out to the server, or the DNS, and the BGP routing takes place in the internet. So if you wanted to use Prolexic for DDoS mitigation, what would you need to do? So first of all, 2 GRE tunnels are set up for redundancy, typically between your edge and our scrubbing center. And then we monitor your infrastructure for DDoS attacks. So we can set off your routers for JFlow or NetFlow, or we have an appliance that can set off a span port. How are we doing for time there, Dean?
Yeah, we're good.
Okay, cool, thank you. And if we detect a DDoS attack, then you, the enterprise, will make a BGP route change. So you announce your network to come via our Anycast network. So that Anycast network is distributed across our 7 global scrubbing centers at the same time. And we have around 3.2 terabits of bandwidth at our scrubbing centers worldwide. So I believe that Akamai is the world's largest procurer of bandwidth worldwide. Would that be? I guess if anyone's got any objections to that, let me know. And so how does the traffic flow go through? So if we're advertising your subnet via the scrubbing center, that means we need to see all the attack traffic, and the flow looks like this. Oh, anyway. The traffic comes from the client, goes through the scrubbing center, so all traffic needs to go to the scrubbing center. Bad traffic gets dropped. We have about 20 technologies there, and we have a security incident response team.
I hesitate to be impolite, but can we get over the marketing crap and get to the technical substance?
All right,
because
cool.
this marketing stuff is kind of, we all get that all the day.
Thank you.
And if you kind of get to what's interesting and unique technically, irrespective of what you're doing in your marketing department, we'd all appreciate it. Thank you.
Thanks very much, Jeff. All right, so what was interesting in this particular period of time last year in Q2 was Australia appeared in the top 10 source countries for DDoS attacks. We also appeared in the top 10 source countries for application layer attacks. And why is that the case? Possibly because there's a lot of Internet of Things devices that are getting compromised. It's not necessarily where the attackers are coming from. These are just the attack sources, so typically compromised machines. How easy is it to do? It's super simple. You can learn on YouTube. You can go and do a free stress test. There's trials available. 200 meg for 300 seconds. You can pay $3.25 for a 500 meg attack. Super cheap to do. DD4BC was doing a lot of this. They send an attack and they send an extortion letter afterwards, and they said, we can send 400 to 500 gig. Pay me to this address, otherwise we'll send a lot of attacks. We saw a number of Australian organizations, I believe, pay. And so what happens there is every other organization in that vertical also gets attacked. So we're seeing that attacks were the biggest in around 2014. We sort of see them taper off. We haven't seen them taper off in terms of the multi-vector attacks, but we see them taper off in terms of the highest amount of throughput, but we've seen them increase in the number of million packets per second. So that's designed to take down core infrastructure in service providers in your network. So by the time these attacks get to you, it's actually a little bit too late. You need to be able to stop them before it gets to your network. What are the industries that are getting attacked? So gaming is the highest that we see, and then software and technology, internet and telecoms, followed by media and entertainment. And how easy is it to do an application layer attack? How are we doing for time, Dean?
Yeah, we're pretty much done.
Okay, all right, cool. So my apologies about making it to marketing. I've got a few more things that are of interest, but if you wanted to have a bit more of a chat about it later, happy to hit me up. Thank you.
Awesome.
Thank you very much. Okay, and our last talk for this session is Masataka Mawatari. And he's going to be talking about 23.128.0.0/10.
Hi, I'm Masataka Mawatari from JPIX. Today, I'd like to talking about the IPv4 address block. It's just informational talk about 23.128/10. This is IPv4 address block reserved in ARIN region It's a remaining IPv4 address block after IPv4 address run out in ARIN. It's for using dedicating IPv4 block to facilitating IPv6 deployment. And the important thing is that minimum allocation size is /28, and maximum allocation size is /24. It's described in NRPM number resource policy manual 4.10. It's our ARIN document. Different from the others. Ordinary IPv4 address block allocation size is /22 or /24. On the other hand, this /10 allocation address block /24, as I talked previous slide. In fact, there are some advertised route. As you can see, route views router. There are 15 route advertised route in route views. Let's deeply dive into this routing table. This 6 routes is advised from Live NCC RIS. It's an experimental routing table. It's not a commercial operation by ISPs. As you know, there are some best kind of practice or textbook about BGP operations. In this slide, BGP document says that don't smaller than 24. So will we add permit 23.128/10 from 24 sites to 28/28? This is a conclusion. Address distribution from this /10 has already started. And as of now, longer than /24 block hasn't been distributed except the Live NCC experimental assignment. So any impacts that doesn't happen. But it's not sure when longer than /24 assignment will happen for non-experiment. Please check your configuration on your router. And last point is address policy in RIRs or NIRs sometimes makes an impact on the network operation. Thank you for your attention.
Thank you very much. Any questions? No? Thank you very much. All right, awesome. That's all the lightning talks we have scheduled